practice. I'll have people read off our learning goals. Let's see. I'll do the second one because the second one we're actually not doing. So I'm going to have Mihaela, will you read off the first bullet point for us, please?
Calculate a value that is a solution to a linear equation in one variable and explain orally the steps used to solve.
Beautiful. Number 2, we're not doing those number puzzles today, so we're going to ignore that. And then let's do the third one. Let's have Abner. Will you read off that third bullet point?
Justify orally that each step used in solving a linear equation maintains equally.
Perfect. Beautiful, beautiful. Okay, yep, learning goals today. We'll be calculating solutions to linear equations with one variable, so that means our x. So we're talking about variables. That means we're solving for our x. And maintaining equality, so that means maintaining balance. When I talk about balance, does anyone know what I mean by balance? Like, what's that rule that we have when we're solving with the sides? Does anyone know that special rule that we're always talking about with these linear equations? Any ideas? With the different sides of the equation? Thoughts? I feel like I've said it a ton of times. It's that rule that what we do to one side, we have to do to the other, right? That's how we keep balance, is by making sure that what we're doing to one side, we are balancing out by also doing it to the other side. So that's what it means by maintaining equality or balance. All right, too much chatter for me. Okay, so this is going to be super helpful. I got this material from another 8th grade teacher from Helms. She shared this with me, and her students have been using this anchor chart. It is so helpful. This is going to be a lifesaver for you in terms of how you're going to be solving equations. It just gives you the steps on what to do next at your final step, when you're starting at your final step, if you're getting rid of parentheses. It gives you all the goods. So I'm going to have everyone pull this up in your Google Classrooms and then just chat, and you can just chat in ready into the Zoom chat once you have it up. So I'll also put this in the Zoom chat, and I just posted it, so some of you may even have it up. It's called Solving Linear Equations Anchor Chart. I think it's just called Anchor Chart, or it's called Anchor Chart in your Google Classroom. Please pull this up. Okay, so currently cohort A is crushing it. I have 4 people from cohort A who are ready, 5 people from cohort A who are ready. So cohort B is behind, 6 people. Oh, Orlando's come in now. He's ready. So I have 8 from cohort B and 2 people, or 8 from cohort A and 2 people from cohort B. So let's get some more. Oh, Leilani's ready. Thanks, Leilani. And I can show you my screen too. It's just under week 33 math, and it's called Solving Linear Equations Anchor Chart. We'll talk about it right now. Thanks, Jose. Let's see. Andrea, are you ready? Elijah, are you ready? Alejandro is ready. Thanks, Alejandro. Okay, so we're pulling this up. It's called Types of Balanced Moves. It's called the Anchor Chart. You can use this whenever you need. It's always going to be in your Google Classroom, so you can just pull it up and refer to it if you're stuck on a problem. So types of balanced moves. And what we mean when we're saying balanced moves is it's kind of that situation for what we're doing to one side, like right here, adding 3, we're also doing to the other side to keep that balance. So for this equation where it says negative 3x minus 3 equals x plus 4, we want to eliminate this constant number of 3, because we like it when we just have our x's on our left side of the equation and our numbers, right, our constants on the right side. And we also want to make sure that we are able to get our x's together, our variables together, and then also our whole numbers together. So that's why there's 2 different ways you can start this problem. You can either subtract, so you can either add 3, because that cancels out, gives us 0, do this to the other side, Or this person is also getting rid of the x over here, where they're subtracting x, canceling that out on that right side. So we just have that 7, because we just want to have, right, we like when we have our whole numbers on one side of the equal sign. And then what we do to this right side, we have to the left side. So then it results in this final situation right here. So these are just some good examples on kind of next steps. You're going to see a lot of problems that look like this. So this will help guide you through the process of solving. Definitely refer to this whenever you need. It will come in a lot of handy. So yeah, definitely keep this up. And we'll keep going. I would keep it up maybe in this next warm-up problem, because I want to talk to you about this one-on-one real quick. I'm actually gonna have Elijah join us too, so I feel like you guys had similar thinking. So Elijah, I saw you didn't answer the next 2, so I kind of want to talk this through and make this maybe a little bit more clear for you guys. This problem, I just saw that you did 1, so let's check it out real quick, and then we're gonna do it full group. But I wish this would load. Okay, so let's first look, and you guys can just come off mute or chat in. Let's look at this step 1. So we're going from 12, actually let's do step 2, because I think this one's the most straightforward. So I'm going from 6x minus 3 equals 5 to 6x equals 8. So what's different about this left side? What happened from 6x minus 3 to 6x?
Did it add?
Okay, so it didn't add, but Leilani, what's missing? Like, right, I go to 6x minus 3, and then I just have 6x. What's just like, what's gone?
The 3.
Yeah, the 3, right? Elijah, can you see that too, how that 3 is gone? That minus 3. So then we're kind of thinking, okay, so then let's look at this next side. How do I get from 5 to 8?
You said what?
How do I get, just in general, like how do I get from the number 5 to the number 8? What has to happen?
You subtract.
So I'm going from 5 and I'm going up to 8.
Oh, I thought you said from 8 to 5.
No, you're good.
Yeah, you add.
Yeah, I add. I'm adding what? And Elijah, what am I adding? You want to come off mute, Elijah? Yeah, okay. Elijah said, yeah, you add the 3. Totally. So if we're adding 3 to this side, and then I'm also adding 3 to this negative 3, because that becomes 0, that cancels out. That's why this one's going to be A. Does that make sense? Yeah, totally. I think just like, yeah, no, and I think it's a simple, I think that's just a quick fix. I feel like it's just kind of a confusing question too, but I would say just like take it slow and just be looking at like, what's the difference between this right side and then from the top right side to the bottom right side, top right side to bottom right side, and really just think about like what's actually going on here. So you guys want to submit those cool downs. I'm going to call on a couple people to kind of share with us their thoughts. Just I saw some really good work in here, so I'm definitely going to have some people share. Okay, let's have I'm going to change the next slide so we can see it out, and I'm also just going to share my screen just to make sure we're all in it. But okay, so here's the question. It says match these equation balancing steps, blah blah blah. We're looking at these bottom 3 things to which goes to which, kind of situation, and we're figuring out how am I getting from 12x to then 6x minus 12x minus 6 equals 10 to 6x minus 3 equals 5. Miguel. So yeah, Miguel, why don't you share your thought process with solving this first step, and then kind of let us know what's going on.
From my side of thinking, I'm pretty sure the first step is just like the most basic one. It's like a warm-up out of this warm-up, because all you really need to do is look at the starting numbers and see what that came up to be. So it's like 12x minus 6 equals 10, and then you just see the bottom one. It says 6x minus 3 equals 5. So it says down there all the 3 options, and I went with divide both sides by 2 because that just seems the most obvious, and also like the entire thing is just like if you multiply the bottom one by 2, you just get the top one either way.
Perfect, Miguel. Absolutely. Yeah. So Miguel also was thinking like if you multiply 6 by 2, you get 12, negative 3 by 2, you get negative 6, 5 by 2, you get 10. Also, listen to my language, everyone. I'm calling this -3 and -6. I know that this is a subtraction sign, but these are still going to be negative numbers in this equation because we're subtracting that number. Awesome. Okay, Mihaela, you want to kind of lead us through this last one?
I mean, like, I didn't really do like any math for this one. Like, it was just like the last card there.
True.
Uh,
Yeah. Oh, Mihaela, I think you might have cut out. That's okay. That's okay though. Yeah, this last one is going to be b then, multiply both sides by 1/6. So that's what we're going to do. All right, let's get a chat, an emoji or a random word from everyone in the Zoom chat. Just let me know you're good to go. We're here. We're ready to keep learning. Thanks, Abner. Thanks, Jonathan. Thanks, Sonia. Thanks, JD. Thanks, Mihaela. Thanks, Leilani. Love to hear that. Thanks, Gabby. Thanks, Elijah. Thank you, Miguel. Thanks, Michelle. Thanks, Jose. Thanks, Maurice. Thanks, Carmen. Love the emojis. Cool, cool. Orlando, Alejandro, are you here? Cool. Making sure. Good to go, you guys. Thanks so much. Okay. We'll do a practice then after this problem. Solve for x. So show me your next steps when we are performing our next steps with this. All right, Gabby, let's talk this through. I feel like it's easier if I kind of hear your thinking, and then I can maybe guide you into a good direction. Okay. So what are you, so you said, what about subtracting 5x? What do you mean by that?
It's because I was used to like leaving x alone. So like trying to take away all the numbers and leaving x alone in one side and then the whole numbers on the other one. So I was like, is there a way I could subtract 5 from x?
Totally. I think that's, yeah, I like where your thinking's going. I also feel like that will help me with addressing it to the class because I think a lot of people do that. So what we want to do is we're kind of chilling with having a 5 and an x together. That's okay for us because we're gonna, at the last step, we're gonna divide that 5 out.
Oh, okay.
Right? So let's look at this anchor chart real quick. So like, for example, in a lot of our last steps for equations, we just kind of want to get our number and our x together. So I know I say like x on one side, whole number on the other. It could still be a number paired with an x because then we can kind of just like think -4 times what number equals 7, and then you can also just divide that 4 out. But I see where your thinking's going.
Yeah, that's what I was thinking. But now
Totally. Okay, good. So yeah, so I would say like first step is if 5x is already on this left side like we want it, to get rid of this 2, right?
Yeah.
And how do I get rid of this 2?
I subtract by 2.
Perfect. And then we also have to subtract it where?
27.
Yeah, good, Gabby. Beautiful. Okay, perfect. I feel like you're good to go. We're gonna keep doing practice because practice makes perfect within this stuff. And now we're adding an extra step. So the last problem you just did, you're kind of just doing like a couple steps. For this problem, you're gonna have to do an extra step. Some reminders of what we're looking to do is we're gonna look to see how we can combine our x's on one side. So let's get our x's, let's get this x with this x, and then let's try and get this whole number 4 with this 10 on this right side. So what we're gonna try and do is we're gonna try and do our, okay.
All
right, let's just walk me through.
Okay.
Okay. And then you can just go back to your Nearpod screen, I think. Beautiful. No, you're all good. All right, 2x plus 4 equals 10 minus x. So what is your ideal next step? And then we can figure out what we can do together.
Maybe subtract 4?
Yeah, good. And why would we subtract 4? Love that.
So we can cancel out the 4. So it only
Yeah.
leaves 2x.
Perfect, Naomi. Good language. Okay, so why don't you show me, so do subtract 4. And then you can also, what we do to that when we're subtracting 4, we also have to subtract 4 from 10, right? Because we have to keep that balance. Good. Perfect. Okay, so then rewrite the equation to what it looks like now. I know it's kind of hard to write.